All right, this is day 2. This is the sheet. Identify our population of interest and the parameter you want to draw a conclusion about. We're going to state the hypotheses in symbols and in words. What our conditions are. So we will choose the appropriate inference procedure and we'll verify conditions are met. The third step, if the conditions are met, we'll carry it out. So we will calculate our test statistic and find our p-value. We're going to interpret our p-value. We're going to make a decision about h-naught. So we're either going to reject or fail to reject, and then we're going to make an explanation of our decision in context of the problem. And then this chart here, I'm just probably going to wait till you guys come back to help you fill that out. So the notes for day 2. Again, you hopefully have copied them already, and we'll just go through them here. So your hypotheses today are in terms of P. This is about the population proportion. Today we're doing a one-sample z-test for proportion. The sample is a random sample, so it should be a simple random sample from the population of interest. Just like in confidence intervals, we're going to check n times p greater than or equal to 10 and n times q greater than or equal to 10. Note here that I'm not using p hat and q hat like I did last chapter for confidence intervals. Again, in this chapter, in your hypotheses, you state that you believe you know what p is equal to. Last chapter, I didn't know what it was equal to. That's why I was using p hat. And then the independence condition, so we're still going to check that n is greater than, this should be 0.10 of n. I'm not sure if it showed up very good there. Actually, I wrote it different last year. I think I changed it on the notes that I gave you. So the lowercase n is less than or equal to 0.10 of bigger n. All right, the test statistic. I gave this to you in the notes from the day before. So this is the z distribution. It is p hat. So it's a statistic minus the parameter divided by the square root of p times q times n. Sorry, these are old notes, and I guess I wrote it twice because somebody was complaining that they couldn't see that probably. We can find our p-value by using the standard normal distribution with a picture. And then we'll interpret. So in this problem right here, so I've got Arnold Handy as a production supervisor for the Spalding Corporation. And he claims that the percentage of left-handed golfers is greater than the 10% rate of the people from the general population who are left-handed. In a random sample of 250 golfers, 15.2% are left-handed. Test this claim at the 0.05 significance level. Is there enough evidence to support Arnold Handy's claim? So a couple things there. So he's claiming that it's greater than 10%. So P is going to be greater than 10%. We get a P at of 0.152. My significance level is 0.05. I'm going to test this hypothesis test. So like I told you back here, you are going to state your population risk. You're going to state your hypotheses in symbols and in words. So over here, what I've done, so I've got P greater than 0.1. That does not have an equal sign in it, so it is going in my null. And then I'm going to write out in words what it is. So P is the proportion of left-handed golfers. This data is from a random sample. It said that it was random. It says in a random sample. The normality check. So I am going to do n times P. Again, it's not P hat. I believe that P is equal to 0.1. So I'm using 0.1 there. It's 0.9, 1 minus 0.1, get 225, that is greater than or equal to 10. One thing to note, your textbook continues writing, it writes the hypotheses this way. A lot of newer textbooks just always leave the null as the equal. So that's why here I'm justified by just using 0.1. And then of course that last condition, and I've been doing it differently this year, but the sample, so the sample is 250 golfers, and surely there are at least 2,500 golfers in the USA. So I can do this two ways. So my conditions have all been met, so I can do this by hand. So if I do it by hand, I get my p hat minus my p, and then divided by the square root. So I've got p hat times, p times q divided by the sample size. And I get 2.741. So that is my test statistic. So it tells me how far away my value is. So this 0.152 is from how many standard deviations it is away. So even by looking at that, 2.741, you can tell that that's unusual because it has a z-score of higher than 2. And so therefore, I'm probably already led to believe that this is enough evidence for me to conclude that the proportion of left-handed golfers is greater than the population. So, but I couldn't find my p-value by hand, so this is still following the standard normal curve. So I've got normal CDF here. I'm just going to use my test statistics, so 2.741, comma, positive infinity, and I get 0.00307. Just like before, there is an option, a way to do this on your calculator. So you can go to Stat Tests, it's number 5, one prop Z test. P naught, that is the number that is in your hypothesis. So in this case, our hypotheses, it is 0.1. So P naught is the number that, so that's where that 0.10 goes. X, so just like last chapter with the confidence intervals, X is the proportion in the sample that have that characteristic. So in this case, your P hat was 0.152, so if I took 0.152 times 250, I believe I get 38, or maybe I rounded that, I'm not sure, I don't remember now. And then your sample's 250. The last thing that you check here when you're doing that calculator command is it asks you to state the direction of the alternative. So you look at your alternative hypothesis, so it's saying that P is greater than that P naught, so I want to make sure that that is the one, so I have prop greater than P naught, that's the one I select. So that arrow there has to match up with the alternative. You press enter, you get your test statistic, and you get your p-value. And obviously the picture would be the same. When we interpret this, so we have 3 parts here to our interpretation. I'm going to interpret my p-value, make my decision about the null, and I'm going to give an explanation. So my interpretation of the p-value. So what the p-value means is there's a 0.00307 chance, or a 0.307% chance of getting 15.2% from a sample if the true proportion was 10%. Reject H naught at the 0.05 level, so I'm rejecting it because my alpha is less than, my p-value is less than alpha. There is enough evidence to support the claim that the proportion of left-handed golfers is greater than 10%. So to summarize what this says here again, so this is my probability of getting this p hat, of getting 0.152 if the true value were really equal to 0.1. It's so unlikely that I would get 0.152 if the true value was really 0.1. So since it is so unlikely for that to occur, the true value probably is not 0.1. So this is probably not true, so I want to reject the null, and I have enough evidence to conclude that the proportion of left-handed golfers is greater than the 10%. All right, I'm not going to go through the other examples. This one was just a less than, so therefore the alternative, when you find your p-value, the alternative is going to the left, so your shaded area is over there to the left. And then I think that I must have 2 different numbers here because you must get a slightly different result when you round using the calculator. And then this one, same thing here, but this is a 2-tailed test. This is the 3rd one. So what you do in a 2-tailed test, if you're not using the calculator, if you use the formula, you'll get this test statistic over here. However, when you started this test, you didn't know what direction it was going to go in. So you find the p-value, so you find the probability of this area, but you also need to find and add it to the probability of this area. So what I did is I found the probability of this piece right here and just multiplied it times 2. If you use the calculator method, it'll just give you the answer. It'll take care of that for you, so you don't need to double it again if you're using the one prop Z test on the calculator. All right, that is it for this one.